Good evening, everybody. I'm super happy and super excited to be here, and we're gonna talk about a topic you would have definitely heard about. And we were just talking about NFTs, and probably you've heard about more than that, a lot more than that. Blockchain promises so much more, like maybe DeFi or something else. But maybe just to get an idea from the audience, if you guys could react, if you already know about blockchain or not, if you've heard about it before, raise your hands or write it in the chat. I just want to take a quick scan. hmm So some people have started raising their hands. Arpit. Abhishek. Okay, so a lot of people are familiar with it. That's wonderful. And those of you who don't know it yet, there's no problem. Stick with me and we'll fix that. Let me start by introducing ourselves. I'm Niharika and I work with Decentology as a product manager. And I've been active in the blockchain industry since my college days, which were in like 2017. I did my bachelor's from India and my master's from Switzerland. And that's where I am right now. And I'm very pleased to introduce you to my colleague and my friend, Nick Kalyani. Nick, over to you.
Hey guys, I'm Nick. Super excited to be here today. Niharika is going to lead you through a very, very exciting demo and presentation about building decentralized applications. This is what our company Decentology does, and I'm very, very pleased to lead the charge where we onboard the first 10 million Web2 developers to Web3. Back to you, Niharika. Thank you.
All right, Nick. Here's what we do at Decentology in a nutshell. Our company is headquartered in the beautiful city of Mountain View in California. And we're very, very passionate about creating products that simplify blockchain development for developers who want to transition into the realm of Web3. Our signature product is Dapp Starter, which we will take for a spin in just about a few minutes. And in addition to business, one of our core principles is to create a more fair, equitable, and a just society. And that is why we go an extra mile to foster gender equity. And here's what we're doing about it. So, if you're a woman and you attended this webinar and you created a project with Starter, which I will show you in just a few moments, you can win a scholarship to University of California, Berkeley's Professional Certificate in Blockchain Fundamentals. For this, all you have to do is write your full name in the live webinar chat and scan a scanned PDF copy of your college ID. And in case you don't have a college ID on you right now, any transaction that you did with the college would be sufficient. We just want to make sure that you're somehow affiliated with the college. So, and make sure whatever proof you provide, it has the same name as you write on the chat. And then we'll get back to you with a form where you will be asked to submit a project link. This can be a GitHub repository link, or if you hosted it somewhere, that's even better. In that case, you can send both the links. So this was the trailer. Now let's just get started. So here, what we see is a very high-level overview of the life cycle of a transaction in a blockchain. So someone sends a transaction to a blockchain, it's broadcasted to all the nodes in the network, and depending on the blockchain protocol these networks are running, these nodes carry out various cryptographic operations to validate the block. And once the block is validated, it's added to the chain. And that's when the transaction is set to be settled or completed. And a nice question to think about right now would be that what gives life to the blockchain? Where are these transactions coming from? So the heartbeat of a blockchain comes from smart contracts. A smart contract is simply a program that runs on the blockchain. It's a collection of code. It can have several functions, and it also stores some data, which is called state, and that resides on a specific address on a blockchain. And in particular on Ethereum, it will reside on an Ethereum blockchain address. So users can interact with it by submitting transactions, which will essentially execute functions defined on the smart contract. And there are three things to keep in mind when you're programming a smart contract. First of all, the immutability of code. So once the code is deployed on chain, there's no way you can change it. So you have to be very careful about what you're deploying on chain. The second is the cost associated with it. So each time your user who's using your application calls for a smart contract function, all those lines of code that will be executed within your smart contract will essentially ask for some money to be paid. Only when you pay some money or gas, those lines of code will be executed on the blockchain. Otherwise, they will not. And if you don't provide sufficient gas or money, then your transaction will fail. The third thing to keep in mind is storage. The smart contract storage is very, very expensive. So storing even 500 megabytes can cost you somewhere around $1 million. So you don't want to do that. What people do around this is they store all of their large files, such as music or movies or whatever, on a separate decentralized storage and only refer to a hash of that file in the smart contract. And we will see that in action in just a moment when I do the live demo. And with this knowledge, we actually have the tools to compare and contrast between Web 2 architecture from Web 3 architecture. And what we see on the slide is a very typical Web 2 architecture that most of the apps follow. And essentially starts with a user who sends a request to a web server, which in turn sends a request to an API server, which in turn talks to the database. And at any given junction here, you can have like multiple of them. So there could be multiple servers, there could be multiple users, and this is typically how a Web 2.0, a centralized application will work. And I hope you're curious to see that how is Web3 going to be different. So here we have a completely decentralized architecture going on. Your client app can be stored anywhere that you want. But for the sake of Web3 ethos, it would be the best if you choose decentralized hosting platforms such as Fleek or IPFS or Saya or Arweave, or you can even research about them and see what works out for you the best. And your client application will essentially be communicating with the blockchain where your smart contract code is residing. And this is essentially, in a nutshell, how your Web3 architecture would look like. And at this point, you might be thrilled about it that, the concept of servers kind of goes away a little bit. And maybe if you continue to host your application on Heroku or something, you still have a server. But like I said, you should definitely check out decentralized hosting platforms. And at this point, you would be surprised to know that you already have plenty of skills to begin your journey as a blockchain developer. So the focus of this slide is to show you that if you already have some kind of a working knowledge of a front-end framework or a library such as React, you already have 70 to 80% of the skills to be a Dapp developer. And all you have to do is learn how to write smart contract. And that can be done in many different languages. If you want to create your applications on the Ethereum blockchain, you have to learn how to write a program in Solidity. On the Flow blockchain, it's written in Cadence. On Solana, it's written in Rust. And on Quantum, it's written in TypeScript. And there are many, many blockchains coming up. For example, Algorand, in which you code in Reach. So you should definitely check out more and more blockchains and see what programming language do they use to write their smart contracts in. Maybe at this point, you're already convinced that you already have most of your skills in your quiver. So a fair question to ask as an undergraduate student would be, how much do these smart contract developers make? And on the slide, you will see some annual salaries based on different regions. So in Asia, in Europe, if you're working remotely, that's also very common these days in Web3, for you to work remotely from anywhere you want in the world. And so, yeah, these are pretty good numbers. And these are quite reliable statistics. So if I was in your place, I would be quite excited to, already start learning one of the smart contract languages and coding it. So at this point, I'm going to take a pause and see if you have any questions. And I'm also going to see the chat if there are any questions till now. And you can also unmute yourself and just ask if you have any questions.
I haven't seen any questions, Niharika. But
Okay.
once again, a quick reminder, if there's any women in the audience, to please look at the chat and share your name so we can get you lined up for a scholarship.
Okay. No worries. In case there is, let me know. And I hope you're able to see my screen again.
Yes, it's visible.
Perfect. So what we're going to do right now is focus on the left-hand side of my screen. We head over to dappscharter.decentology.com, and what we're going to do here is fill out this nice little form and tell this what kind of an app do we want and what kind of a blockchain do we want to use and everything. And it's going to create a repository, a full stack repository for us. So let's get started with it. For this webinar, we're going to choose the Ethereum blockchain. And you would see that in the next tile, we see the language as Solidity. If I select the blockchain as Solana, you would see that the language changes to Rust. So let's go back to Ethereum. And there are two frameworks from which you can choose. And I would say that we should start with Vanilla.js. And the good part about Dapps Charter is that we'll have several web components. So even if you want to include React in your project, it will be very simple. And if you use any other framework, such as Angular, even then it's going to be very easy for you to do that.
Hey, Niharika, sorry to interrupt real quick, but there's a question about what is a smart contract from Aryaman?
All right. Aryaman, okay, thank you for your question, Aryaman. And so let me go through it again. So smart contract is essentially a piece of code that resides on the blockchain. And whenever a user interacts with it in form of triggering an event or triggering a function, the code starts executing on the blockchain. So in a moment, we'll see a smart contract live here, which will be running on the blockchain, and you'll be able to, glean more from the context. But in a nutshell, all it is a simple code. It has a set of rules about the application, and that runs on the smart contract. So I hope I was able to answer your question there. And if there are any other questions, please let me know. And okay, so coming back here, so there are several smart contract features or design patterns that we abstracted and converted them and bundled them into these modules. So for example, whatever features you want your Dapp to have, you can select them here. For example, I'm going to select this option, contract run state. That will give my Dapp the ability to pause the operation of the smart contract. And a very cool use case for that would be when a hacker, you might have heard about news that some hacker invaded some smart contract and drained it of like $100 million or something like that. A very good thing to do at that point, if you are the developer of that smart contract which has been compromised, would be to pause that contract so that no other user can engage with that contract or interact with that contract. So you essentially halt the operation of your contract. And you can also definitely resume it once you fix it. The next feature that we will be seeing is file storage. A couple of minutes ago, I talked about decentralized hosting, and I talked about IPFS and SIA. So let's also include IPFS in our application. And finally, we would give it a name. So we can just give it anything you want, test maybe. And once you click on this button, oops, it's just going to ask me to log in, which is not going to take too long, and that's done. We just name our Dapp anything we want, and we click on Create Dapp. And behind the scenes, what it's going to do is create a full stack repository for all the choices that we made. And you can see that it generated this GitHub link. And if I click on it, you would see this is a full-fledged, full stack blockchain application. And for the sake of saving some time here, what I did was I already cloned this repository on my machine. And the output that you're seeing on the right-hand side in the terminal of VS Code window is when I clone this repository, I ran yarn. So all those who are familiar with NPM would know that when you start a project, you have to install your dependencies, and you can do it with npm install. And in case of Dapp Starter, instead of using npm, we are using yarn package manager. So all I did was run yarn in that project.
Niharika, for those who wouldn't know, would you mind just popping up a new terminal window and typing in the exact command they would use, git clone and the URL?
Oh yeah, of course.
You don't have to
So
actually do it, but just show the command, please.
yes, of course. So all you have to do is copy this here and write git clone and paste it there. And what it's going to do is it's cloning this repository. And when that's done, you cd into this repository and you're there inside of it. And when I said I ran yarn, this is what I did. Then I press enter, and then it's going to go into the loop of installing all these dependencies.
Niharika, sorry, I didn't expect you to type it. It's going to mess up your other install now, but let's hope it didn't.
Oh,
yeah, I didn't expect you to actually enter on there, but that's okay. Let's go back to the one you had already done.
All right, so this is the one in which I already did it, and I got this success message. So now what we want to do is actually start running this application. So in order to do that, I would type this command yarn start and hit enter. And what it's going to do in the background is, first of all, run a local blockchain emulator. That means it's going to be running a local blockchain of Ethereum on my machine. And that is Ganache. And it's a very common tool. You can check it out online. The other thing is that it's going to compile all the smart contracts. Remember the features that we selected, all those are actually coded within the smart contract, which we'll see in just a second. It compiled all of them and deployed them to the local blockchain emulator that we're running. And the third thing it did was it spun up this beautiful client, and which we see right here. So this is the page where you would delete all this code and create your own application. And for the sake of this demo, I'm going to first show you the smart contract features I was talking about: contract and state and IPFS documents. And you would see that in addition to these two, we also have administrator role. And within administrator role, it's a dependency that contract run state needs. So only the administrator of the contract can pause the operation of this contract and nobody else. So the code generating engine that created this repository was intelligent enough to know that so administrator role is dependent on contract run state. So let's import that as well without the user having to select it. So let's check out contract run state. So we see these two action cards here with one of them saying view and the other one saying submit. So let's see if the contract right now is active or not. And it says that yes, it's active. And right now, if I let's say that there's been an attack and some money has been draining out of my contract, and I want to pause it. So what I would do is change the run state of this contract, and you would see this switch widget right here. If I check it, it means that it should resume or start working again. If I uncheck it, it means that it should not be working. So I wanted to stop. So I click on submit here. And what it did was it submitted a transaction to the blockchain with this account. And we get this transaction hash right here, OXE700. And on the right hand side, if you see the VS Code terminal, this transaction also ran on the local blockchain emulator with the same transaction hash OXE700. And this is the amount of money or gas that it used. And what's the block number? And this just says at what time was it mined. And if I click on this view button now, it should essentially say that the contract is not active anymore. And if I try to interact with it, it will not work. So when I click on view, I actually see that the contract run state is not active anymore. So that means that this contract run state worked all right. So let's turn it back on again. And bam, that's done. So this was a gist of contract run state. Now let me show you IPFS documents. And here we're going to upload a document, and we're going to make sure that these documents are not stored on any centralized database. They're all hosted on a decentralized database. So let me upload this file right here. It's a city, and let me name it Michigan. That's the Michigan city, and let's click on submit. And what it did was it uploaded this file on the blockchain, on IPFS, not the blockchain. And it stored the hash of the blockchain of this file on the smart contract. And this hash in turn is stored on the blockchain. And you would say that if you had to store this file exactly on the blockchain, that's going to cost you like a lot of money. And that's why we choose a service like IPFS to save costs there and improve our efficiency. So the IPFS URL is mentioned right here. And if I click on it, it will take me to IPFS gateway. And if I paste this URL in the chat right here, you'd be able to see the same on your machine. So it would be awesome if you can confirm, if you can click on the same URL and see it on your machine as well. Just write it in the chat if you can see it. I am not able to see the chat right now, but okay, let me go. All right, so my friend confirmed that it worked for me. Did it work for all of you guys? Okay. Perfect, Nishul, Arpit. Awesome. So it's working. So that proves that this is not hosted on some random centralized database, but instead on a decentralized server. And here we see other data that was returned to us. For example, this transaction hash, which is going to be the same again if we see our terminal right here. OXC18, and this is going to match this transaction hash here. And for each document that we upload, we're going to generate a unique document ID so that if you want to query this document, we can use this ID directly. So let me copy this document ID, and let's try to get this document using the document ID. So I pasted this ID here, and I click on view, and then it returns me all the important stuff about this document. So what was the label that I gave it, the Unix timestamp, and this is important, the owner who actually submitted this document. So each time when I say that your user is interacting with your smart contract, what it means really is that there's an address on the Ethereum blockchain which is constantly interacting with your smart contract. And in this case, I uploaded this document as an administrator. And down here you see this address here, OX4A1DB. So this is admin's address, and that's exactly what I used to upload this file. And now if I want to see that what documents are uploaded by the owner, let's say admin, I click on view and it returns me this document ID, which is exactly the same as this. And there are many more test addresses that you can use. For example, if I want to see if Birbal uploaded anything on IPFS, the results should be null because Birbal did not upload anything. And we see that it's actually blank. So Birbal, it verifies that he did not upload anything. So this was an overview of the two contract features that we selected. And now we're going to see how to actually program this. How is it all made? How is the front end connected to the smart contract? How is the smart contract written and all of that? So I'm going to take a small pause here again to see if everything's good or if some things you're not able to understand. I'm happy to go over it again. All right, if that's not the case, let's get into the code then. So here, let me open this folder in which we are doing all this work. Okay. I hope this did not stop. Okay, so let me run yarn start again. It stopped the server. In the meantime, let me just tell you how the file structure has been organized. So within packages, this is the place you'll be working the most within this packages folder. It has three subfolders, client, dapplib, and server. In the first folder, the client folder, everything you see here, for example, this dappiness, your Dapp is ready, and UI harness, all of this is within the client folder. And if I show you how to change something here, we go in the source folder within the client folder, then within pages, then dapp.js. And what we're seeing in this file is exactly the output that's on this file. So if I change this dappiness to hello world and save it, this project will hot load it, and you don't have to stop this terminal from running and save it and then restart it. It's going to all load automatically. So as you can see, it changed, and this is hello world. So if you want to make any other changes here, if you want to import your own web components here, feel free to do that. And this was the client folder. The next folder is dapplib. That's where most of your interactions with the blockchain will occur. And within that, you will see a very important folder called contracts. And within this, all of our features which we selected would be there. So in dappstate.sol, when you see a .sol file, it means that it's a .solidity file. And immediately you would know that it's running on an Ethereum blockchain or an EVM-based blockchain. When I say EVM-based, it just means that it's going to be running the same protocol as Ethereum does. So it's also going to use Solidity as its smart contract language. So apart from Ethereum, which uses Solidity, other EVM blockchains such as Avalanche or Conflux, they also use Solidity. And within dappstate.sol, you would see all these features. So let me show you about IPFS. So here we see all the states and data about IPFS. And here we have about contract run state, the events that it emits. and events that are emitted when we add a file to IPFS. So all the code is there and it's heavily commented. So I would definitely encourage you to make your own repository and go through all this. And I think that will be a quite fun exercise. And here we see this function called isContractRunStateActive. So it returns a Boolean value, which means that if it's true, that means that the contract is active. If it returns false, that means it's not active. And in the second function, where we say set contract run state, where we want to either pause the operation. So let me go back here in UI harness again and show you this. So the second function, which you see on line number 169, that's essentially referring to the second action card here on the left-hand side of my screen. And this here, right here, is capturing my Boolean value, whether it should be true or false. And dappstate.sol is this. And a great thing to point out right now is that initially I told you that whenever you deploy a smart contract on the blockchain, it's impossible to go there and edit it. So a question that should probably pop up in your mind, and it probably has popped up in some of your minds, would be if you want to upgrade your smart contract, or add more features to it, or delete some features from it, what will you do? So the answer lies within dapp.sol, what I'm about to tell. So our client will be interacting with just one smart contract. Your application can have like maybe 10 smart contracts and each of them doing a different task. But essentially here, dapp.js, our client will be interacting only with dapp.sol. And this dapp.sol in turn references to dappstate.sol, where we had all of these other functions. So Dapp.js is always going to be pointing to dapp.sol, and dapp.sol is pointing to dappstate. And whenever you want to change what dapp.sol is pointing towards, you can change that. And so essentially your dappstate.sol is then fluid. You can make whatever changes you want to it. And dapp.sol will never change. And this is going to be immutable forever. And so now we also discussed the smart contracts. And now let's see how are we interacting with the smart contracts? How is the client interacting with the smart contract? And the answer lies within dapplib. If you go into the source folder and you go on dapplib.js, you'll see that this is essentially a library where all of the functions that are in the smart contract reside. So if I show you within dappstate, that's all, is contract run state active, you will definitely find the same function within dapplib.js, which is right here. On line 15 is contract run state active. And the way this works is that your client side will never be interacting directly with the smart contract. It will never directly interact with this .sol file. It will always route its request through dapplib.js. And for each function in dappstate.sol, you write a dapplib function, and it should replicate the name of the function right here in this line. So this function name should be exactly identical to the name of the function you have here in your smart contract. And on line number 17, you see that this is doing a blockchain.get. So with AppStarter, we try to use Web2 analogies such as get and post. So when you're getting something from the smart contract, or if you're querying the blockchain, it's going to be free of cost. You don't have to pay any gas. And on the UI, you would see that's indicated by this green button with view. So whenever you see this green button with view, it means that you don't have to pay any additional cost to query the blockchain. However, If you want to post something to the blockchain, if you want to add something there, it's always going to cost money. And in the next function that I'm about to show you, set contract run state, that's telling the blockchain that, okay, for this smart contract, you have to pause the operations. So that's writing something to the blockchain, and that's always going to cost you some gas. And in this example as well, you see that on line number 42, this line, this term should be exactly the same as this function name of this smart contract. And in this one, we see that it's always going to be blockchain.post. And you would wonder, how is this capturing the input parameters? So the way it does is that in the next line, when you mention your function name, in the next line, you tell data.mode. And what it's doing is mode is going to capture the Boolean value. And the variable name here, mode, should be exactly the same as it's written here, mode. So it's going to capture the Boolean value, and it's going to send it over to the smart contract. And when we're getting something from the blockchain, usually there's no parameter, but in case there is a parameter, then you would put a comma here and write something like data dot um, whatever is the name of your variable, let's say mode again. So yeah, that's that. And the next thing you would do is how would you create these action cards, right? So let me show you an example of that. Let me show you this exact page. Just a moment. This was, wait, I'm in Dapplib. I should go to client, source, harness, and within harness, I want to see the contract run state. I open this, and this JS file here, right here, it shows us this exact page. So we have two action cards here, the first one and the second one. And in the first one, we are seeing title, description, action, method. So action card right here is a web component with a bunch of several properties such as title, description, action, and method. And in here, you can see there are a whole bunch of web components that we have created for you. Action card is one of them. Action button, such as view or submit, is one of them. And you see here the way we're capturing the Boolean value. That's a switch widget that captures the Boolean value, and there are like a whole bunch of more that you can explore. So the title property of this action card is responsible for this line here. So if I add something trivial here, for example, 3 dots and tell me please. If I save that, it's going to change it right here. So title is going to change that. Description is going to change the line below it. And the third property, action, this is the meat of it. This is where all the action is taking place. And this should exactly match the function name that you have within Dapplib. So in case of this action card, I want to make sure that we are querying the blockchain and we use this function name. So this name right here should be identical to this right here. And the next property is method. Method could be get or post. You get a method, you use the get value when you want to fetch something from the blockchain, and you use the post value when you want to write something to the blockchain. And if I change this to post, it's not going to do much, but all it's going to do is change the CSS around this action button. It's going to turn orange and it's going to start saying submit. But you don't want to mislead your users, so you don't write post and you instead write get right here. And in the second action card, we see the post property. All of this remains the same. Action again points to which function in dapplib should this point towards? So within dapplib, it should be pointing towards this function. So this name right here should be identical to this. And the method is again post. And a very important property here comes into picture, that is fields. That means what parameters should be passed on to this function right here. There could be one, or there could be more than one. So if, let's say, we capture A, B, and C, let's say there were like 3 more variables that we had to pass. So we just hit space and just write them there like that. And within that, you would see the switch widget is nested right here, and that's capturing the Boolean input. And with the input that it's capturing is mode. So here, a subtle difference is that here it was plural fields, more than one parameter can be passed, and within switch, it's fields, so one parameter can be passed. And switch widget, like you know already, captures the Boolean parameters. So this is how action cards are made. And if I want to do something on my home page right here, wait, yeah. If I want to change all of this, let's say that I want to copy this action card, which allows me to pause the operation of the smart contract. In here, I would just copy that web component and come back here. And let's say I want to delete all of this, and I paste this action card right here. And I already see this action card running here then. And what we are seeing right now is a small problem. The switch widget is not showing up, and it's not actually a problem. It's only because the switch widget is not imported here. So whichever web components you're using, make sure that you have a reference to that in the same file, otherwise it will not work. So after making this change, there it is. It starts working. So this is how easy it is to customize your Dapp and play around with it and, you know, create a UI. And this is like all full stack. And I would say that you should also head over to dappstarter.decentology.com and create your own project and play around with it. And especially for the women who are attending this webinar, I would encourage you to do so. And if you do it, you get to win a scholarship to this $200 course from the University of California, Berkeley. It's a professional certificate in blockchain, and you'd learn a lot more about it. And with this, I would conclude my demo and open the floor for questions. So let me know if there are any questions.
Niharika, I just want the audience to know that we have an active community where they can get help on Discord. And I'm going to post the Discord link here in the chat.
All right.
So please join our Discord.
Yes, absolutely. If while making your project, if you get stuck anywhere, or if you need help from us, to kickstart your project, just hit up on our Discord, and we'll be happy to help you. Yeah. And there are like many more members in our team who are very kind to support you through your journey of blockchain development.
Yeah, I'm really interested to see more women if they are in the audience to respond. Also excited to see your questions. We've been doing this webinar for various different schools, various other NITs, various other IITs, and one of the things I've found is there's been a lot of interest and a lot of good questions coming from the audience, and hoping we can get some more questions here.
Muskan, it's a scholarship at decentology.com, not scholarships.
Oh, sorry, that was my mistake. Then I pasted the wrong address. I thought it was scholarships. So my mistake.
No worries.
Can we add the alias for scholarships also, please? Because
yeah, of course.
That's what it was supposed to be, and that's what I've been promoting. All right, looks like NIT Rourkela has no questions for us, which is a first. Uh, hey, Subhadeep, it's kind of late. We've just wrapped up the session, so you may have to watch a recording. We introduced you to how to build Dapps, and you can check out our app building platform at dappstarter.decentology.com. The link is right here in the chat. I'm going to post it again. You can also join our community. All right.
All right, so Abhishek is asking, how can we access the recording? Vinay, how can the students access the recording?
Yeah, they will be posted in the group. We'll also share the YouTube links with them, right, as soon as they're ready.
All right,
Uh,
perfect.
so what we'll do is we'll ask the organizers to circulate the links of the recordings as well, so that everybody here can actually go through the lecture again and at least try and build their own app, build their own app, and definitely go to Decentology Discord channel, so that if you guys have any question while watching those recordings, please so that you can ask your questions in that group, and the active community will reach back to you guys. Right. Thank you, Nick. Thank you, Niharika, for such an enlightening lecture. And we'll take over from here and share all the links, relevant links with everybody, as well as the video links, the video recordings as well, so that they can go through it. Right. Thank you so
Thanks,
much.
Thank
everyone.
you.
Have a good day. Bye.
Bye bye.
Bye bye.